Your workshop is noisy, but here's the problem. Knowing the noise level at one machine doesn't tell you if your workers are at risk. A worker spends 2 hours on one machine at 82 decibels, 4 hours somewhere quieter at 77 decibels, and another 2.5 hours on a loud press at 89 decibels. Is that safe? The answer lies in a single number, your worker's daily personal exposure level. In this video, I'll show you exactly what it is, why it matters legally, and how to work it out using the HSE Ready-Reckoner table, and in the last, we will verify it using Noise Exposure Calculator Excel sheet. What is Daily Personal Exposure Level, LEP? Here's what it does. It takes all the different noise levels a worker is exposed to throughout their shift at different machines in different areas and combines them into a single number that represents their total daily dose of noise. And here's the key, that daily dose is normalized to an 8-hour working day. Why? Because the UK Noise at Work regulations set their legal limits based on an 8-hour shift. So no matter if someone works 6 hours, 8 hours, or 10 hours, you convert their exposure to a standard 8-hour equivalent so you can compare it fairly against the law. Under the control of Noise at Work regulations, daily personal exposure level is the number that decides what you must do to protect your workers. The law sets 3 key trigger points. Below 80 decibel A, the worker is below the lower exposure action value. Good news, no mandatory action required beyond basic measures. 80 to 85 decibel A, the lower action value zone. At this point, you must offer workers hearing protection, provide information and training, and start thinking about noise control measures. 85 decibel A and above, the upper exposure action value. This is where mandatory controls kick in. You must provide hearing protection as a requirement, designate areas as hearing protection zones, offer health surveillance, and implement engineering controls to reduce noise. 87 decibel, the absolute exposure limit value, accounting for hearing protection. This is as high as it legally goes. So calculating LEP, D is not just for interest, it directly determines your legal compliance and what controls you must put in place. 2 ways to measure daily personal exposure level. Option 1, sound level meter method. You measure the average sound level daily personal exposure level at each location where your worker spends time. You record how long they spend in each location. Then you combine those measurements and durations into a single figure. This method takes planning. You need to visit each workstation, measure the noise, and track worker movements, but it's very practical for one-off assessments. Option 2, noise dosimeter method. You clip a small sound meter onto a worker's shoulder. They wear it for their entire shift. At the end of the shift, the dosimeter gives you the daily personal exposure level directly. This method is more hands-off. The worker goes about their day normally, and the dosimeter captures everything. It's also more accurate because it accounts for all their real movements and exposures throughout the day, things a single walkthrough might miss. If you use a dosimeter, you can skip the calculations below. You already have your answer. If you use a sound level meter, keep watching. Let's walk through a real example. I'll use the HSE Ready-Reckoner table to show you how it works. Imagine we've measured a worker shift and found Machine 1 82.5 decibels for 2 hours, Machine 2 77.6 decibels for 4 hours, Machine 3 89.4 decibels for 2.5 hours. Question: what is the worker's daily personal exposure level? So, you measured your noise levels, but you have a problem. Your readings are decimals, 82.5 decibels, 89.4 decibels, and your shift times are odd, like 2½ hours. When you look at the HSE Ready-Reckoner table, these exact numbers aren't there. The table shows 82 and 83, but not 82.5. It shows 2 hours and 4 hours, but not 2½ Do you guess? No, you use interpolation and the split time rule. First, machine 1, 82.5 decibels for 2 hours. The table doesn't have 82.5. So we look at the neighbors. Find 82 decibels at 2 hours. That gives us 13 points. Find 83 decibels at 2 hours. That gives us 16 points. Since 82.5 is exactly halfway between them, we take the halfway point between 13 and 16. Halfway between 13 and 16 is 14.5. Machine 1 equals 14.5 points. Next, machine 2, 77.6 decibels for 4 hours. This part of the table skips rows. We have 75 decibels and 78 decibels. At 78 decibels, 4 hours, the table gives 10 points. At 75 decibels, 4 hours, the table gives 5 points. Our reading is 77.6 decibels. That is very close to 78 decibels. It's not quite 10 points, but it's much higher than 5. A safe, precise estimate here is roughly 9 points. Machine 2 equals 9 points. Now for the tricky one. Machine 3, 89.4 decibels for 2½ hours. The table has no 2.5 hour column. The rule, when you have a time that isn't listed, break it down. 2½ hours is just 2 hours plus 30 minutes. We calculate points for both and add them together. But we also have 89.4 decibels, which is between 89 and 90. Let's find the points for both 89 and 90 first. Step A. If it were 89 decibels. 2 hours at 89 decibels equals 65 points. 30 minutes at 89 decibels equals 16 points. Total for 89 decibels equals 65 plus 16 equals 81 points. Step B. If it were 90 decibels. 2 hours at 90 decibels equals 80 points. 30 minutes at 90 decibels equals 20 points. Total for 90 decibels equals 80 plus 20 equals 100 points. Step C. Interpolate for 89.4 decibels. We are looking for 89.4 decibels. That is roughly 40% of the way from 89 up to 90. The gap between our points 81 and 100 is 19. 40% of that gap is about 7.6 points. Add that to our base of 81 and we get 88.6 points. Machine 3 equals 88.6 points. The final sum. Now we just sum them up. Machine 1, 14.5 points. Machine 2, 9 points. Machine 3, 88.6 points. Total exposure points equals 112.1. Finally, convert points back to dB using the right-hand table. 100 points equals 85 decibels. 125 points equals 86 decibels. Our total is 112, which is right in the middle, actually slightly closer to 100 than 125. If we interpolate that gap, 112 points converts to 85.4 decibels, and there you have it. The worker is over the upper exposure action value of 85 decibels. Now let's check the same calculation on exposure calculators.